Okay, last class we talked about functions, and a function was a situation where each x value is only allowed to have one y value. So in an arrow diagram, each x value can only have the one y value. Now there's a special kind of function, a subset of functions called a one-to-one function. And that's the case where each y value can equally only possess one x value. So we tested to see if something was a function by seeing if it satisfied the horizontal line test. So this parabola, I draw some horizontal lines. Anywhere I draw it, I only cross the graph once. So I can happily say, yes, it is a function. When I draw horizontal lines instead of the vertical lines I drew, I find that the horizontal line crosses the graph in more than one case. So in this case, it's not a one-to-one function. I come over and look at my straight line graph here, y equals 2x plus 1. Wherever I draw vertical lines, I only cross the graph once. So yes, it is a function. Is it a one-to-one function? Well, now I draw horizontal lines. It doesn't matter where I draw them. I only cross the graph once. So it can be considered a one-to-one function. Whereas when I looked over here, I've got a y value of, I don't know, that looks like about 4. Y value of 4 here. It's got an x value of 2. Sorry, negative 2 and 2. So even though each x value only has one y value, these y values map back to 2 possible x values. When I look at a cubic, it's a function. Look, I can draw horizontal lines, vertical lines everywhere. And it also passes the horizontal line test at every point on the graph. Now that's not the case for every cubic. If you remember our cubics, we might have a graph that looks like that. Yes, it passes a vertical line test. Doesn't matter where I go, I would pass the vertical line test. And in some places, I pass the horizontal line test. But I get to somewhere like that, I definitely fail it. It's not a one-to-one function. Semicircles are similar. Here I've got a semicircle. It would pass vertical lines, but it's clearly not going to pass the horizontal line test. The interesting thing about semicircles is I could have a semicircle that looks like this, doesn't pass the vertical test, but would pass the horizontal test. So we need to be really careful when we're looking at circles and semicircles. We want a one-to-one function that's a semicircle actually needs to be half of a semicircle, a quarter of a circle. Okay, something else that we need to be aware of is a piecewise or hybrid function. Now we can build a function out of a cubic or quadratic, out of all sorts of different functions, and we could make it one-to-one by putting restrictions on our domain. When we put those restrictions on the domain, we might actually build various different parts of the function. So here I've made a restriction. Whenever x is less than 1, my f of x or y equals 3. What does that look like on a graph? I go up to an x value of 1. And I've got a horizontal line, y equals 3, all the way there, up to 1. It's not allowed to ever equal x equals 1, so I've got an open circle at the end. But for any value of x less than 1, my y value is 3. So that's part of my graph. Now, I know that the y equals negative x graph would normally look like this. So I'm just going to draw it in with dots for the time being. Now I'm told between 1 and 5. So from 1, 2, 3, 2, 3, 4, 5. I'm allowed to use this graph. So now I'm allowed to equal it, closed circle, closed circle, and there's the second part of my hybrid graph, and I can delete those dotted, oops, too much. Delete those dots. And then the third part of my graph is a parabola. So I would know that a parabola would have looked something like that, but I can only go from 5 onwards. So my curve is going to go like that.